Hello again. We are continuing our discussion on solving quadratic equations, but I'm going to do things a little bit backwards. We are going to be given the solutions and come up with the equation instead. So we're using the roots to write quadratic equations that would actually have those solutions or roots. Okay, so if I gave you the solutions and asked you for the equation that had those solutions, how would you do it? Well, let's do some examples and we'll kind of see the process. It's basically the backwards of what we've done in the last lesson where we were factoring and then coming up with our solutions that way. So if I asked you to write the equation for the given solutions x equals -3 and x equals 2, remember how we would get those solutions is we would be solving linear equations that had those solutions. So if x equals -3 is a solution, then I'm looking for a linear equation that has that solution. So I can come up with x plus 3 equals 0 because -3 would be a solution to that equation. Similarly, if x equals 2 is a solution, then I can create a linear equation x minus 2 equals 0 because 2 would be a solution to that equation. And then once I have my two linear equations, I can take those expressions on the left-hand side of each of them and multiply them together to get x plus 3 times x minus 2 equals 0. And then to come up with my final quadratic equation, I can multiply using distributive property the x plus 3 times the x minus 2 to get x squared plus x minus 6 equals 0. And that is the quadratic equation that has -3 and +2 as its only solutions. All right, so let's do another example. It's a pretty tricky process, but the more you do, the better you get. So we're going to write an equation that has solutions x equals -5 and x equals +5. All right, so if x equals -5, if that's a solution, then I can create a linear equation that has that solution, x plus 5 equals 0, because -5 is a solution to that linear equation. Also, if x equals +5 is a solution, then I can create the linear equation x minus 5 equals 0, and that has 5 as its solution. So now, if I multiply those two linear equations together, or at least the expressions on the left-hand side, I would get x plus 5 times x minus 5 equals 0. And you can see that -5 would be a solution to that, and +5 would be a solution to that as well, depending on which set of parentheses would end up equaling 0, making the whole thing equal to 0. So I multiply those two sets of parentheses together, and I get x squared minus 25 equals 0. And that is the quadratic equation that has -5 and +5 as its solutions. All right, now let's talk about what would happen if I only wanted one solution to a quadratic equation. Now, we've seen that before. It's where the parabola ends up crossing the x-axis only once. Or when you factor something, you get two identical factors. So let's look at how we would create the equation to do that. I would need to write an equation, for example, that would have only one solution, x equals -4. Well, if x equals -4 is a solution, then I can create a linear equation, x plus 4 equals 0. And -4 is clearly a solution to that. But there's no other solution, so I can't create another linear factor. Otherwise, this would have two solutions instead of one. So what I do is I take that linear factor and I multiply it by itself. And that way I have the same solution twice, which really doesn't change how many solutions there are. So I take x plus 4 and I multiply it by itself, and I set that equal to 0. Because now I have a quadratic equation, not just a linear equation. So I get x squared plus 8x plus 16 equals 0. And that's the quadratic equation where the only solution would be x equals -4. So I think I've gone through enough examples for you to get an idea of how to do this. If you have any questions, please let me know, and I will see you tomorrow.